Okay, good morning everyone. Welcome to the first session. We're going to hear 5 awesome talks about generation. The first speaker is Yannis Koskins from UW.
Thank you very much everyone for coming here today. So this is joint work with Srini Iyer, Mark Yaskar, Yejin Choi, and Luke September. And I'm Yannis Constance, and I'm currently a postdoc at the University of Washington. But we start a new job as an assistant professor here at Wood University in September. So I'll be happily recruiting new PhD students, so please come talk to me. Right. Okay, so a quick overview of the work is the following. We start from an AMR graph, and we'll talk more about AMR graphs in a moment. And we generate text using a sequence-to-sequence neural network with attention, as well as train a separate sequence-to-sequence model where we start from text and we pass to the AMR graph. Now, sequence-to-sequence models, just like any other machine learning approach, need usually a large amount of data in order to thrive, to work sufficiently and be competitive with existing models. However, the existing AMR corpora are more like on the small side. So we therefore address the low resource problem by introducing pair training algorithm, which is basically a generic framework for performing data augmentation by scaling small domains using unlabeled corpora, and achieve state-of-the-art performance on the task of generating from AMR. Right, but first let me do a quick overview of what AMR is. So abstract meaning representation is a formal meaning representation of language, which is represented as an arbitrarily nested complex structure, which is described, as you can see on the right, by a directed acyclic graph. Okay, here is a tree, but you can have the entrances which end up having critical graphs. Now, nodes are concepts, and these correspond to nouns, verbs, named entities, and so on. And the edges correspond to semantic roles, that is, relationships between consecutive concepts or nodes. So for example, for the concept to know, arg0 corresponds to who's doing the learning, so I'm doing the learning in that case. And arg1 in that particular example corresponds to the object of learning, so the planet, I know the planet, and so on. So we will address 2 tasks, namely getting an AMR graph as an input and outputting the sentence that best describes that. And we'll also focus on the reverse task, so we will start with the input text and then parse it to the resulting AMR graph. Right. So parsing to AMR and generating from AMR can be useful in many applications, such as, for example, text summarization. Imagine a scenario where you begin with a bunch of sentences, but you get to parse into the corresponding AMR graphs. Then you compress them together in a single unique AMR graph, and then generate the resulting summary from there. Or similarly, in NP, usually you start from the source text and then you go directly to the target text. But there are cases where you can instead go from the source text to the source meaning representation graph, the graph-to-graph transformation to the graph of the resulting target language,